We are on the last page of the notes, working on this problem right here. In terms of y, describe the values of x for which that curve will have a vertical tangent. What does it mean for the tangent line to be vertical? What's undefined? The slope is, or the derivative is undefined. All right, so let's take the derivative. Oh, have we done that? Have we done part of it? Oh, is this for the same problem? Yeah. So tell me what the derivative was again. dy dx equals?
Minus 3x squared over 3y squared minus 4x.
And it says in terms of y, find x. Okay? So that denominator has to be 0, correct? Now it says in terms of y, so what this means is we want that to say x equals. Well, if we add 4x to both sides, correct? So any time that x is equal to 3/4 of y squared, that thing's going to have a vertical tangent line. Did you have any trouble finishing? Because I know we didn't finish this one. Did you have trouble finishing it on your own? Well, all right then, good. Why did I only do the bottom? Because for a line to have, to have a vertical tangent line, that happens when the slope is undefined. And slope is undefined when you have a denominator of 0. So I only was concerned about the denominator. All right, so we have 2 more questions to look at. And notice on both of them, notice what they are asking. Have we talked about that notation?
Yeah,
that means second derivative. Did we talk about that? I have no idea why the 2's are where they are. Okay. But I'll ask him someday. That's right, because I'm sure he has a special place in heaven since he discovered calculus. At least I hope he does. Hope everything else was good. How do we take the derivative of y squared plus 2y equal 2x plus 1? 2y dy dx. What the crap is that? 2y dy dx plus what?
2 dy.
Good. 2 dy dx equals 2. So dy dx correct? So dy dx is 2 over 2y plus 2. Now that's what dy dx is. Now I've got to find the derivative of that, correct? All right. Mm-hmm. Mm-hmm.
Like on the notes, it looks something over there.
What did he do? Oh no, it. Okay. What the author did is he just rewrote this as y plus 1 to the negative 1 power.
Oh.
So you, yeah, so you can do the peanut instead of the quotient, and it doesn't matter which way you do it. Emily.
Could you also factor out the 2 from the start?
Where?
When you factored out the dy dx, could you also factor out the 2?
If we had done that, so let's see. If we had done 2 dy dx, like that, times y plus 1 equals 2, how would you go from there? You'd have to divide both sides by 2 times y plus 1. Same thing. So yes, absolutely. Absolutely. Now, again, I don't care if you do this as quotient rule or if you rewrite it as y plus 1 to the negative 1 power. It just doesn't matter a bit. Did you have a preference? No? All right. The derivative of this is d squared y over dx squared. Let's do quotient rule. Derivative of the top, 0 times the bottom, 0, minus the derivative of the bottom is dy dx times the top over the bottom squared. Now, that's ugly. What is dy dx? That. So we're going to substitute. We're going to substitute that in for dy dx. So what we're going to have here is negative 1 over y plus 1 all over y plus 1 quantity squared. Yep. Because when we did the derivative of this using the quotient rule, the derivative of the top was 0 times the bottom, so that's 0, minus the derivative of the bottom times the top. Now let's take a look at this. Dividing by y plus 1 quantity squared is the same as multiplying by 1 over that. So this is going to give you negative 1 over y plus 1 quantity cubed. And you'll get that either way. Don't leave your second derivative with a dy dx in it. Substitute what you got for dy dx in there. You practice. I don't have a better answer for you than that. You guys try this one. Uh-huh. Okay, you guys are working it. I'm just going to work it up here with my mouth mumbling a little bit. 2x plus 2y dy dx equals 0. Please. So dy dx equals negative 2x over 2y. D squared y. Derivative of the top is negative 1 times the bottom minus the derivative of the bottom times the top over the bottom squared. So that equals negative y plus x times negative y Wait a minute. Hold it. No, I'm fine. Yeah, I'm fine. Up right before the bell rang. So is there anything that we need to talk about at this point with your implicit differentiation? All right, then what we're going to do, you're going to have this time do the homework, and I'm going to give you some free response questions from previous year's exams that have implicit differentiation. So I will give you those, and you just have the rest of the period to work on implicit differentiation. Okay?